Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today I was going to run a simulation. So we'll go back to using our studio. And this simulation is about waiting time in a queue. And this is a very common thing we do, say, in operations research or queuing theory. And the idea is just I will take a very simple scenario here. We have like a fast food chain and we have a drive-through window, only one window, and we are getting customers and we want to see during rush hour, do we have enough servers or should I add another server or add another line? Um, so we are looking at how long does a customer stay in line and how many customers do I have? Because if I get a customer who needs to get some, say, fast food, and they found that the queue has like 7 or 8 cars, they wouldn't go, right? They would say, why should I wait all that time? I have to return to work, and they would leave. So I don't want to lose customers. And let's take a very simple scenario. I want to see how long would it take me to serve. Let's make the numbers, I mean, not non-realistic, but easy. So I'm going to say I'm getting a customer every minute on average. And usually, when you study these things, again, you might have seen people with stopwatches looking at how fast cars are coming and leaving a queue. And that's a study we do. It's called time study, where we would collect the data and then try to fit a distribution and say, okay, it looks like, they are coming. If you remember what we did in probability and statistics, this is a very common thing. It's called a Markovian arrival. Markovian meaning it follows the Poisson distribution. And if you were alert, you would have noticed that when we were covering the probability distributions, we said that if the arrivals to any place, like a queue, for example, follows the Poisson distribution, then the time between arrivals, which is a continuous random variable, would be exponentially distributed. So if both the arrival as well as the service follow the Poisson process and the exponential distribution, we refer to them as Markovian. And we use the letter M, uppercase M, to represent. So when you see, for example, it says MM1, it means the arrival is Markovian as well as the service. The service also is Markovian, and I only have one server. If it's MM2, I have two servers, and so on and so forth. And usually we don't say that the population is infinite. That's the default. So we don't say MM1 infinity infinity, where we say the system is infinite and the population is infinite, meaning I can have theoretically infinite people in my location, which is absurd. But again, this is the simplest case, is to say infinity, infinity, and MM1. We are not going to do the MM1. I will change a little bit in I'm going to make it MG1. G stands for generic. So if you pick anything other than Markovian, it's generic. So I will make the service time normally distributed just to change. It's not a big deal. So let's see what information I want to collect to answer my questions. So I may have a table. Let me draw a table here. In the first column, I would enter what we call the inter-arrival times, meaning the time between arrivals. Okay, and you say, how do you know those? No, I don't. We collected data with stopwatches, and we found that they are exponentially distributed, the time between arrivals. So inter-arrival time, and this one is exponential with lambda equals 1. meaning 1 minute. 1 minute, every minute on average, I get a customer. Of course, you know that the time between arrivals is exponentially distributed, and the exponential distribution has a large standard deviation. In fact, the standard deviation equals the mean, and the mean is 1 over lambda, which is 1. So 1 minute is the mean, and 1 minute is the standard deviation. So I may get two customers right after one another, and then I may wait like 2 minutes or 2.5 minutes without having any customers, and then I get one, and so on and so forth. So this is called the inter-arrival times. So for the first customer, I start at time 0. Let's assume we want to say how fast can we serve 30 customers, okay? So when the first one arrives, and let's say this is at time 0.6, that person will go in service right away because there is no one in line. He's not going to wait, right? So the arrival time is also 0.6. Okay? Now, after that, we have, I'm going to add two more columns later, but for now, I'm going to say the service time. And let's assume the service time here, as I said, is normally distributed. The problem with the normal distribution, 1 square, which is still 1, but I prefer to write mean and variance for the normal distribution. The normal distribution, it goes from negative infinity to plus infinity. So what if it selects a random number for me and it's negative 1.5 minutes? What does that even mean? It doesn't make any sense. So let's say, just for the sake of argument, I'm going to say it's the absolute value of that. And let's say the first one I received was 1.2 minutes. Then I can calculate the departure time, which is the arrival time plus the service time. So the first customer leaves at 1.8. In fact, as I told you, I want to add them later, but maybe we can add them now. I want to add one after the arrival time. So between these two guys, I'm going to call it n sub I, or n going into the system. So I'm going to write just the 1 for that. And then for the departure time, I want to have n out, so the number of people leaving the system, and it's -1. We'll see how we are going to make use of those columns. So this would be filled with ones, 30 of them, and this is -1, -1, 30 of them. So this is customer number 30. Customer number 2, the inter-arrival time, meaning between the arrival of the first and the second, I may get, say, 2.4 minutes. That's not the arrival time of the second customer. Be careful. That's the time between arrivals. So I have to add these two together and say, so the arrival time for customer 2 is 3. Okay? But when customer 2 arrives at time 3, customer 1 has already left. This car has already left. So it's not going to wait for service. Would go right away. The service time, let's say, is 0.9. So I add them up and I get 3.9. The third customer, and then I'm going to stop, suppose came with 0.7 inter-arrival time, meaning 2.4 was the previous customer, and plus 0.7, it's 3.1. Oops, can't go in service right away. I need to take the maximum of these two values because I still have car at the window. This car cannot move. Okay, so we'll have to wait until this customer leaves, and I will update that and make it 3.9. And then let's say this is 1.5, you add them up and you get 5.4, and so on and so forth until I fill the table. So how do I do that in RStudio? Okay, notice that when we say the arrival time, I'm going to add these two up and then compare them. So again, I add Point 0.6 and 2.4, I get 3.0. I cannot write it right away. I have to check the departure time of the previous guy. And if this one is larger, I use it. If this one is larger, like for customer 3, I say, nope, I'm going to use that. But for the first customer, I don't have to do any of this because the system is empty. Once the person arrives, we'll go right away and order. The problem we had last time we did a simulation is the same here. Our studio start with an index of 1, not 0. So I cannot write a statement for customer number 1 by himself or herself and then change that for number 2, because here I cannot say, oh, the arrival time is the maximum of the inter-arrival time or the departure of the previous, because there is no previous, there is no 0. And that's why I'm going to write for customer number 1 a special values, and then after that the rest will be in a for loop, and my for loop will start from 2 all the way to 30. Okay, so that's the first problem we have. And then once we fill this table, we are going to talk about how we make use of these values. Okay. Sometimes you can add another column. I don't want to make it more complicated, but if you are writing it, you can add a column here. I'm not going to add it, but you can say, okay, waiting time in the system, WS, waiting time in the system. And all of this is departure time minus arrival time. Okay? So it's not this number, because this number is the arrival at where to place the order, like to the microphone or to the window, whatever it is. It's not the arrival time. The arrival time was 3.1. That's why it's a little complicated. So I don't want to. So basically, you get this number from the summation of those. Okay. So 2.4. And I'm going to say 2.4 plus 0.7 is 3.1. And I subtract it from 5.4, which is departure time. So the time the car arrives to the queue, not necessarily to the window, until it leaves. But I'm not going to do that because it's going to be more complicated. In fact, I'm not even going to enter the inter-arrival time. I'm going to call this column 1. The n sub I is column 2, because every time there is an arrival time, I will add 1. And then this is the service time would be 3, the departure is 4, and the number out is 5. So I would have 5 columns. So let's go there at our studio and start clearing the system. List equals ls. Oh, what do I have here? Oops. I will have to say n equals 30. These are the 30 customers. I want to check how long it's going to take to help them. Remember, after that, we are going to create the matrix. I'm going to call it matrix maybe times because, well, it has times and numbers, but I can call it my matrix like I usually prefer to do. Oops, I clicked the caps by error. My mat is a matrix, is full of zeros that has n rows and 5 columns. Good? So far, so good. Now, if I ask you, what is in column 3? You'd say, let me look at the table. Oh, that's service time. It's not really easy, right? Keep saying, should I subtract 2 from 5 or 3 from 4? I have no clue. So we can call the names. We call our columns names. So column names of my mat equals. So now I'm going to refer to them with names. How do I do that? I say equals. It's a combination. So I'm going to combine first column, second column. So the first column, we are going to call it arrival time. You say there is inter-arrival time. No, I'm not going to use that. We'll see how. Second, I have n into the system, number in this going into or coming into the system. Then I have service time. Then I have departure time. Then I have number out. Oops. So I came here and I forgot to do number out. Okay. So now I entered all of these. I created a matrix. Now, if I run this, you can see here the matrix. It doesn't have V1, V2 like we are used to. No, I named the column, so it makes easy for me now to write the equations. As I said, we are going to fill in some stuff. So for example, I'm going to fill for customer one. So I'm going to say my matrix of 1 and 1, which is the arrival time, right? Notice inter-arrival time is the same as arrival time for this customer because there is no one in the system. So I'm going to say equals R exp of 1. I'm not going to enter the rate because the rate is 1 and that's the default as you can see on the screen. So I only enter the number. It's only I'm going to create one value, which is the arrival time. I can type, by the way, in the same line, I can say my mat. Oh, I didn't do my mat. I want to fill all of ni's with 1. The second column, it has to be full filled with 1, right? Ones, all of them. Oh, I'm sorry, it's frozen, but you can see ni, it has ones underneath it. So I can say everything in 2, meaning all the rows and the second column equals 1. And in fact, since I did that, I also can say, instead of 2, again, I said I'm not going to use numbers, and then I use the number. And then I can say my mat of everything and out, which is column 5, equals -1. So I got done with all the columns, so I don't need to worry about them in the for loop. It doesn't make sense to say, oh, every time you change I, write a 1 here. Why not fill them all the way? Now, I still have, and again, this is the arrival time. I don't want to use numbers, so it's less confusing, okay? Then I would say my mat of 1 and service time equals, remember we said we need the absolute value of our norm of 1, meaning mean of 0 and a variance of 1. But I'm going to use the absolute value. So if I get a time of -0.7, it will make it positive 0.7 and so on and so forth. And finally, to finish customer 1, I would say my matrix of 1 and departure time equals my matrix of 1 and arrival time. Let's move this to the next row so you can see the whole thing. Plus my mat. I increased the font so you can see it, but it makes it hard to fill everything in one line. 1 and service time, right? The departure time is arrival time to the queue, to the server, to the service, not arrival time to the queue. But for the first person, the arrival time to the system is the same as the arrival time to the service, right? And that's it. So I'm done with number 1. I will go and do a for loop, but now my I is in 2 to n. Let's write the code. So for the arrival time, okay, how can I find it for any customer after customer one? So I'm going to say my math of I and arrival time is the maximum of, notice, the arrival time of the previous customer plus the exponential time between the arrivals would give me the time the customer arrives. Like 0.6 plus 0.4 will give me 3. But then I have to check the departure of the previous customer, and I take the maximum of these two. Okay? So that's what we are going to do. We are going to say, oh, I'm sorry, this should be I. I don't know why I wrote one. I keep writing one, and it's I. Okay. It's the my math. So the arrival of the previous customer, I minus 1, and arrival time, oh, I need the maximum of this guy plus the inter-arrival time, which is REXP1, right? And my math, uh, I minus 1 and departure time, And where is the parentheses? Okay, now it's correct. Let's reduce this so you can see the whole thing. Okay? So do you see that? Yeah, we have this correct. So we are done with the arrival time. Next, we do the service time. The service time is the same as before. So I can pick this thing, except other than 1, I will change the 1 into an I and write it here. Okay. It's a normally distributed random value. And finally, the departure time. And again, I'm going to take this, copy, and paste, and change that into an I, this one into an I, and this one into an I. And I'm done. I'm done really filling the whole matrix. In fact, if we run this, let's run it. Hopefully there is no typo. No, there isn't. So now I can look at my math, and it's filled with 30 rows, right? 30 rows. In fact, we finished the 30 customers in 36 minutes. Okay, but that's not the whole story. I still need to know what was the maximum number of people in the system at any given time. What was the worst case, right? Do I need to add another line or another server to cook faster, but if I add a server without adding, say, a station where I receive the order, it won't help, right? So maybe I will need 2 lines, like you've seen in many fast food chains now. They add another line so that you can get 2 orders at the same time and finish faster. Okay, and all of that is based on data we receive, we collect, right? It's not haphazard. Now, the problem I have, let's go here and look at the problem we have. Oh, it's frozen again. Oh my God. I don't know why it does that. Okay. Okay. The problem I have is, how can I count the number of people? I differentiate between arrival times and departure times, because every time I have a number here, I want to add 1 to the number of the customers, and if every time I am under DT, I need to subtract. And here is a very nice thing we can do. Remember that we can combine remember the letter C, we can create a vector. And this vector, I'm going to call it T because it's going to take time, right? And I'm going to combine the arrival times and the departure times. Oops, arrival times, everything is uppercase, or else it wouldn't recognize that. But it's not just the arrival time. I have to say where to get it. So you have to say my mat, arrival time and departure time. I'm sorry, I forgot to do that. And then I'm going to create another one for the numbers, but I cannot use n because n here is 30. So I'm going to use uppercase n. And I'm going to say this also is, I'm going to combine my mat n I and n o. And I think I have to write my mat also, right? Yeah, my mat this, or else I will get an error. I have to define it like that. And my mat of and out. Okay. So now it's going to combine all. So on the top, there would be the arrival times. Underneath them, there would be the departure times. And for n, it will have n sub I and in on the top. So 30 ones and then 30 negative ones underneath them. But that's not what I want, right? Because now there are two different vectors. How do I connect the vectors and make them two vectors in like one list, so to speak? How do we do that? So maybe we give it another name. I'm going to call it Tn since it has times and numbers. And this would be the keyword in RStudio is cbind. I'm going to bind these two together. Okay, so I'm going to say cbind what? T, so T and N, right? We call them lowercase t and uppercase n. So T and N. Now let's run these two lines or these three statements because we have T and N and then Tn. In fact, we can call it T uppercase N. I don't care. Well, let's do that. So at least it would be the same. Now, if I run these two lines and then look at the new vector, oops, what happened? Let me see, T. If I say view T, just view T, I can see from this. I think I wrote V. Yeah, it doesn't have anything. It's my mistake. I did something wrong. T, it should have taken a vector of all the numbers here. I is 30. That's a number. Oh, yeah, I see it. I have every time you refer to a matrix, you have to show rows and columns. I want to collect all the rows and the column of AT, all the rows and the column of DT, all the rows and in, and all the rows and out. That's why it give me not available. Okay, I'm sorry, guys. Let's do this. It's really hard to type. I placed the laptop on a higher place on the table, so I won't be looking down between the paper and the laptop. You may not be able to see that, so it becomes really hard and to concentrate. I'm sorry. Anyway, here it is. Now it should be working. Yes. So you see the top 30 are not the songs you think of. No, The top 30 are filled with ones because they are arrivals, and the bottom 30 are filled with negative ones because these are departures. So now I need to do two things. I want to arrange them in an increasing order of the time, both columns, okay? I want to write point 3 first and then compare one with the departure down here, which one is larger, and so on and so forth. So how do we do that? So now we learn how to make two vectors and then attach them together. Now we are going to say Tn, the one I have now that has two columns, I'm going to say it's the same Tn, but now I'm going to, what's the key word here? Order. We put them in an increasing order, and that's the default. So I will, let's see, order. And you can see when I say order, it tells you decreasing is false. So it's an increasing. If I want it in a decreasing manner, I would say decreasing equals true. But in this case, I have, of course, I want it to be false. So what do I need? I need to order based on the first column, right? So I want to say uh, we have now the t's. So let me show you. We have a column having t and a column having n. Oh, I'm sorry, I'm losing this. It's not going to work. So it asks you which column do you want to order by? And you would say, I want to order by T. Okay? Which rows? All the rows. So now if I run this line and I look at the Tn, oh, you see now I have 1, 1, -1, -1, 1. So arrival, arrival, departure, departure, and so on and so forth. Nice. One more step. This is telling me just 1 or -1. That's not what I want. I want to see how many are in the system. So I want to keep adding. So this would be 1. I want here 2, and then 1, and then 0, and then 1, and so on and so forth. Every time I add whatever is. So remember the key word for that? Or we didn't cover it here, but you must have heard this word before, or this term before. It's cumulative sum. Q sum, and it's CUMSUM, cumulative sum. So Tn now, I want to do what? I want to take Tn itself, but then I want the cumulative sum of it. Oh, so let's delete that. Let's write so you can see what would happen when I say cumulative sum. What do I want the cumulative sum of? The second column, right? It's not the first column. I want the second column. So I would say everything and 2. And in fact, I want this everything and 2 to become cumulative sum of Tn everything. Oops, I'm sorry. So what does that say? Take the cumulative sum of the second column, everything in the second column, I'm sorry, and let it replace the current second column. So let's run that and see what happens. So if I go to Tn here, oh, finally, if notice we are not writing to another file or anything, I can simply on the screen, instead of saying cat and write, you can do all of these formatting and embellishments. All what I want is the maximum. I want the maximum T. So I want the maximum of Tn of everything in one, because that would give me the total time I took to serve 30 customers, and then the maximum of Tn everything in two, that will give me the maximum number of people in the system. So if I run that, I get the maximum number in the system was only two, but it took 42 minutes, 0.86. If I run it again, of course, I will get a different value. So let's run it one more time and see what we get. This time, less time, it took 37 and a half, not 42, but also the maximum was two. So I would say if the maximum number in the system is two, I don't need to add servers or lines. It makes sense. Maybe the time is a little bit, so maybe I will train my servers to be more efficient, quickly, working quickly, specifically during rush time, rush hour, okay? Worst case scenario, this is only 30 minutes or 40 minutes. I will get someone to help, a helper. So maybe somebody to bring the bread and whatever and prepare the, salad and stuff. But at the time, another guy was like, cooking the meat or doing something. So they help and reduce the normal time from having a standard deviation of one, maybe to have a standard deviation of zero point 0.5, and that would shorten the time. Okay? That's how we are going to treat the problem. Finally, maybe I want to show you something else quickly. I know we are taking too long, but I want to show you how we plot that. So I'm going to say quartz because I have Apple. I don't have Windows, so I'm not going to say Windows. Okay. I'm going to plot the T and the N, meaning I'm going to plot um, T, Tn, everything in one. That's the X. And oh, it's an uppercase. I thought I pressed the caps, but maybe I haven't. Tn of everything in two. I want the color. Let's say it's red. And then the X label is time. The Y label is number in the system, comma. And the type is important because now I'm not going to use L like I used to do. Now I need the type to be a step function. Every time I go up or down by one customer, I want to see that. So S for step. Something else I wanted to talk about. Should we have to add anything else? No, uh, we don't need to add an AB line or anything. I think this is enough. Just also for the time. So we don't have time to lose. And here you go. So we ran it. The maximum number of customers was two most of the time. Oops. I don't want this to be here. I don't know why it's keep doing this. Okay. So I had one customer and then my server was idle for quite a bit, and then one, and then back to two, and then back to one, back to two, zero, and then one, and so on and so forth. All these values at the bottom are where the server um, was idle. So you can calculate the utilization. We can do much more calculations, but I thought the time wouldn't be would be too much. So I think that's, oops, oh my God. It doesn't matter. It will start at the same thing, but I think we are done anyway. So here is what we typed. You can see it took like 28 lines, but most of it are either blanks or, we were making not really much. All the meat and potato are in these three lines. That's what modeled the whole situation. And after that, it was just cutting and pasting and arranging and sorting. And I hope this was nice, easy for you to follow. If you have any questions, please let me know in a comment. And of course, RStudio is not the best tool to model that. There are other computer languages, simulation languages that are much easier with animation and everything. But I said, since we are doing, statistics and calculations, let me show you how you can model even something like that. Um, okay, so as I said, if you have any questions, let me know in the comments section, and I will try to get back to you as soon as I can. Thank you very much for watching. Have a great day.